Now we are having revision of the slope and calculus 1 subjects, derivatives here. And we were talking about this is we are talking about this point here, how we express it. This is y2, this is x2, and this here we can write it like that: x2 and we can comma y2, comma y2 in brackets. So every point is referred by an x and with y. So this here is x2 and y2. Okay, so here and this point here is x1, y1, and the slope here, is difference of y over difference of x. So difference of y is y2 minus y1, y2y minus y1, and x2 minus x1. And here we have derivative right and y dy over dx. And you know, the derivative of a line here, this is equation of a line, y equals mx plus b. M is the slope, and y here the y axis intercept is b. What is y axis intercept? The place where it cuts b, y axis is b. Okay, here, and we can write derivative of this here with respect to x like this one. So what is this one? This is a is constant, and here x to the power n, we can have it n multiplied by x to the power n minus 1. Okay, so derivative of a polynomial. Take my thing here. Okay. So here a polynomial is in this form, an equation in this form. By the way, I want to make clear what is an equation. Equation is an thing which we have this equality inside. We have cases where we don't have equations. For example, this is y is bigger than this one, or these are inequalities. We can have some inequalities. Okay, so whenever we say an equation, we have to have this equality sign in between. And this is a polynomial, and the degree is n. Here, the derivative with respect to x, we are using the exponential formulas here. We multiply by n and subtract 1 from the power of each one. Now, here, let us explore these two examples here. Okay, and I will make this bigger from current slides. Okay, here. And I'm going to have the laser pen. Okay, that's better. Now, this is an equation, okay, and n, degree is n. Now, and this is the line of this equation, this graph of this equation. And here, when we take derivative according to x, okay, so what happens? We apply the exponential formulas here, and it is a multiplied by n x n minus 1, and we apply the exponential formulas, and this line here is the derivative of this polynomial here. Okay, so there are numerical derivatives slope between points. So let us explore this graph here. Here you can see that this is cosinus x graph, and this is sinus x graph. You can see this, and we know that sinus 0 is 0, sinus 0 is 0 here, and here it's I write period of both sine and cosine is 2p, the interval is 2p, the period is 2p here, and when we take derivative of sinus x according to x, derivative of sinus x, this one, according to x, we have cosinus x, we have this one, this is so interesting, and when we have derivative of cosinus x according to x, derivative of this cosinus x, this one, this cosinus x, okay, we have this one. So this is minus sign, it is just the opposite. So they are, when we take derivative of this graph, it's just opposite of this one. It's minus sinus x. Okay, so this is a graph of partial derivatives. Okay, and this is a graph of these functions here. Okay, this is a graph of these functions here. And okay, so there are lots of deep mathematical explanations of these graphics. Now, this was just an introduction here, and I'm going to stop this presentation. And the next course, I have to share my screen to say what is the next course from the canvas. So I open the canvas. No, yes, tomorrow we are going to see integration techniques, including integration by parts, integrals involving trigonometric functions, trigonometrical substitutions, and partial fractions, improper integrals, comparison tests, convergence, divergence, and improper integrals. So we are going to see these subjects next course.